Alright, so today's lesson we started in class is covering 7.1 and 7.2, talking about different properties of exponents and how we can use those properties to simplify expressions. Okay, so first off, what is an exponent? Okay, remember that exponents represent repeated multiplication. Okay, so with this number example, we have 2 to the 5th equals 2 times 2 times 2 times 2 times 2. Okay, that's 5 times. So it's 2 times itself 5 times, and we can calculate that that is 32. Okay, in general, we say that the number that is being raised to a power is the base, and the power it's being raised to is what we call the exponent. Okay, so if we had x to the n, that would mean it's x times itself, whatever n is, that many times. Okay, so if it was x to the 7th, then that would mean it's x 7 times. Okay, the next question was what should we remember about exponents? So some things to keep in mind would be, first of all, that a to the 0 is always going to equal 1, except 0 to the 0 is kind of a weird case where we don't have that. If we have a negative exponent, then we can think of that as 1 over whatever the base is to the positive version of that exponent. So for example, if I have 2 to the negative third power, that's the same as 1 over 2 to the third. Okay, another thing to remember is that we cannot combine with addition and subtraction. Okay, so like 2 to the third plus 2 to the 7th, I can't combine that. Unless, of course, we have the same type of thing, meaning the same variable and the same exponent. So if I had like x squared plus 2x squared, I could write that as 3x squared. Last thing on this slide is that even though we can't combine with addition and subtraction, we can combine with multiplication and division if the base is the same. Okay, so like if we had 2 to the third times 2 to the 4th, then we can combine, and we'll see how to do that on the next slide. Okay, for this next slide, we're talking about the different rules that we have. So first off, what are the rules for multiplying and dividing? Well, for multiplying, look over here. Okay, for multiplying, if we're multiplying, we have the same base. So here the base is a. Okay, the exponents can be the same or different. But when we have the same base, we add the exponents. Okay, so multiplying means that we add the exponents. Our numerical example over here says 4 to the third times 4 squared equals 4 to the 5th. So adding 3 plus 2 gives me 5. And I can kind of see why that makes sense, because 4 to the third looks like this. It's 4 times 4 times 4. 4 squared looks like this. There's 4 times 4. You're multiplying them, so really all you've done now is create a long chain of multiplication of 4s. So instead of just having 3 and then 2, I could say I have one strand of 5, which would be 4 times itself, 5 times, or 4 to the 5th. Okay, for division, if we have a power divided by a power, or an exponent, okay, and then divided by same base but another exponent, then we can subtract. So how multiplication goes with addition, division goes with subtraction. Okay, here's our example. Okay, we can kind of see why it's subtraction is because things are going to cancel out. So if I had 7 2's on top, 4 2's on the bottom that are being multiplied, so 2 times 2 times 2 times 2, 7 times, and then 2 times 2 times 2 times 2, the 4 times on the bottom. Anytime I have the same number over itself, it's like just having 1, right? They cancel out. Those cancel, those cancel, those cancel. So it's just 1 times 1 times 1 times 1. Which I don't really need to think about, right? I just am worried about what's left, which would be these 3 2's over here. So I'm left with 2 times 2 times 2, or I could just say 2 to the third. And of course, if I look, I've got 7 minus 4 because I am looking at subtraction. So 7 minus 4 gives me the 3 for 2 to the third. Okay, final rule on this slide says what about a power to a power? So if I have an exponent and then that's being raised to another exponent, I have to follow this rule, which says if I have a power to a power, we multiply. Okay, and here's kind of an example showing why. Let's say I have r to the fourth, then raised to the third power. That means I have 3 copies of r to the fourth being multiplied to themselves. Okay, so that means if I look back at the multiplication rule and follow that one, I add those 4s, so 4 plus 4 plus 4 gives me 12. Okay, so the shortcut that we can use here is power to a power we multiply. 4 times 3 equals 12. We're going to move on and look at some examples on the next slide. Okay, anytime there is not an exponent, we assume it's an invisible 1. Okay, because I have 1 copy of it, right? So this is k to the first times k to the third. If I multiply, I add the exponents, so that's going to be k to the 1 plus 3, which would be k to the fourth power. Okay, looking at the second example, I have m to the fourth times m squared multiplying, so I add the exponents, which means I have m to the sixth. When I add some other things into the problem, so like I have numbers going on here, remember that with multiplication, it's commutative, so you can rewrite this. So I'm going to put the numbers first. So 2 times 9, I'm going to put those first, and then I'll put the q's together. 2 times 9 is just 18, and then I've got q squared, q to the fourth. I'm multiplying, so I add the exponents, and 2 plus 4 gives me 6. Okay, once again, I could put the number first, so this would be 2. I have q squared, q to the fourth, multiplying, so I add the exponents, 2 times q to the sixth. Okay, here again I can put the numbers first, so negative 2 times 6. I've got u squared, u to the sixth. These multiply and give me negative 12. These multiply and I add the exponents since the base is the same. 2 plus 6 gives me 8. Okay, next example, I've just got my 9. I'm going to combine, I've got w squared, w to the sixth, multiplying, so I add the exponents. Then I've got x to the eighth and x to the fourth, multiplying those, so I add the exponents and get 12. So that's my answer there. Okay, looking at some division examples now. I have m and p here. I'm going to kind of think of it just like the multiplication ones, except now I'm subtracting the exponents because it's division. Okay, if you look back at the last slide, when we divide, we subtract the exponents. So this gives me m to the 4 minus 2, and then p to the 2 minus 1. Remember that invisible 1 there. 4 minus 2 means that I have m squared. 2 minus 1 is just 1, which I could just leave as p. Okay, some more complicated division ones. I've got p 12 with a 12 exponent on the top, 2 on the bottom. That means I do 12 minus 2 as the exponent. T has a 3 and an invisible 1. So that's 3 minus 1. R, these are both 1, right? So it's like 1 minus 1. Or I could kind of just realize that they're going to cancel out, right? Down here, 12 minus 2 gives me p to the 10th. 3 minus 1 gives me t squared. 1 minus 1 is just going to be 0, and remember that anything to the 0 is just 1. So I don't really have to include that in my final answer. Okay, and final example, two more examples with division. So here I notice I have d to the fourth and d to the fourth on top and bottom. 4 minus 4 is again going to give me 0, so I can just cancel those out. Same thing with the f, they're both to the third power, so those cancel. I'm left with c, it's to the fourth on top, squared on the bottom. So I've got 4 minus 2, which leaves me with c squared. Okay, remember again, just to kind of go back to where this comes from, that means I have 4 c's on the top, 2 on the bottom. So 2 of them cancel out, I'm left with those 2 on top, which gives me this c squared. Okay, looking at now the last division example. I know it's going to have A, B, and C. A has a 7 and a 5. 7 minus 5 gives me 2. B has 8 on top, 1 on the bottom. 8 minus 1 gives me 7. C has 8 on the top, 7 on the bottom. 8 minus 7 gives me 1, which I could just leave as C. So there's my answer there. Okay, hopefully you're starting to see how these can go pretty quickly once you get the pattern. Finally, a power to a power example. Remember, this is like 3 squared twice for this 3 squared part. Power to a power we multiply, right? Or with our rules, it's a power we multiply. So this is 3 to the 2 times 2, which would give me 3 to the 4th power. That's being raised to the 4th power. 3 to the 4 times 4 equals 3 to the 16th. You could also just multiply all these to begin with, since it's just power to a power to a power. 2 times 2 would give you 4, and then times 4 gives you 16. Okay, which is a crazy big number, like 43 million. Okay, exponents make numbers get really big really fast. Alright, moving on now. So this is where we got to in class. Okay, so continue on from here. If you, for the homework part, unless you were absent, of course, then you need the first part as well. Okay, so this is another rule. What if we have a power of a product or a quotient? So basically this is saying we've got stuff going on inside parentheses, and then we're raising that to a power. So power of a product, okay, product means multiplication. So that means I've got multiplication going on inside parentheses, and then it's being raised to a power. The rule here is that basically we distribute the exponent to each piece. Okay, so if I have things being multiplied and then raised to the m power, it's equal to a to the m times b to the m. Okay, here's an example. This one's getting right into it, going a little crazy, but hopefully not too bad. Sorry, crazy zooming happening. Okay, so to the third power means I'm going to kind of distribute this 3. So you can see in our final answer, it ends up as 2 to the third, y to the third, z squared to the third. So it's a power to a power, so we multiply and get 6. Okay, this kind of breaks it down though, so let's see what we get here. To the third power means it's repeated multiplication 3 times, that whole thing 3 times. I gather the numbers, so I've got 2 times 2 times 2, that's this part here. Okay, then I've got y times y times y, so that's this part. Then I've got z squared, z squared, z squared, and that's what's giving us that last piece. Okay, the 2 times 2 times 2 goes to 2 cubed, or I could write it as 8. And then y times y times y gives us y cubed. Z squared times z squared times z squared would be z squared cubed. Power to a power, you multiply. Okay, so I get that z to the 6th. Let me erase this kind of messiness going on now. All right. Similar thing happens when we have a division problem going on inside the parentheses. Okay, we say the power of a quotient. Quotient goes with division. Okay, it's the answer to a division problem. So if we have division going on, same thing. That exponent kind of distributes to the top and the bottom, okay, to each piece. So that means if I have 3/4 to the third power, it's going to end up being the same thing as 3 to the third divided by 4 to the third. Okay, we can see that because it's just 3/4 3 times. So I would multiply across the top, it's 3 times 3 times 3, and then across the bottom is 4 times 4 times 4. So I end up with 3 to the third power over 4 to the third power. So let's look at putting kind of all this together in some example problems. Okay, so starting off a little lighter. This is a product, right? Multiplication to an exponent. So I'm just going to kind of distribute that exponent. So that's going to give me x to the 6th power. Y to the power to a power means I'm going to multiply those. So 4 to the times 6. So I get x to the 6th, y to the 24th. Okay, here again I distribute, oh, I almost missed. I need to distribute to every piece, so to the 4, to the a to the 4th, b to the 9th, and to the c. Every piece that's being multiplied, you need to distribute that to each piece. So 4 to the 2nd power gives me 4 squared. This is a to the 4th to the 2nd power, so a power to a power I multiply. B was already being raised to the 9th, so it's 9th and then squared, so I multiply. C squared. Okay, it looks a little crazy, but hopefully it's not too out there. Okay, it's just kind of, it's like a new way of distributing, okay, distributing with exponents. So 4 squared, that's the same as 4 times 4, so I can just simplify that and write 16. 4 times 2 here gives me 8. 9 times 2 gives me 18, and then the c is just squared. Okay, moving on, third example here. This is cubed, so I cube each piece. So the -2, the f, the g, and the h. So that gives me -2 cubed. Be careful with that negative because that means we've got -2 times -2 times -2. Negative times a negative gives me a positive, and then a positive times a negative gives me a negative. So I'm going to end up with -8 there. Okay, but kind of moving on to the rest of this. So I've got f squared, but then to the 3rd. So it's a power to a power we multiply. G's to the 3rd, and then to the 3rd. So power to a power we multiply. H is squared, and then to the 3rd, so a power to a power we multiply. Okay, so this was kind of figuring out the -2 part. F 2 times 3 gives us f to the 6th. 3 times 3 means I've got g to the 9th. 2 times 3 means I have h to the 6th. All right. Moving on. Distributing that. This is just a power to a power. There's only one thing here, so that's going to be c to the 3 times 2, which would give me c to the 6th. Okay, here distributing this 2 to the -3 and to this. This is all being multiplied overall, so I can just kind of continue writing. So I've got -3 squared, and then c to the 5th, and then squared, so power to a power we multiply. -3 squared, negative times a negative is a positive, so -3 squared is just going to give me a positive 9, and then c 5 times 2 would be c to the 10th power. Hopefully you see that we can combine these, so we can take it one step further. I'm going to write the 9 in front, and then I've got c. These are just being multiplied, so I add the exponents, which means I have 9c to the 16th. Okay, so kind of combining things that we've talked about. All right, these are getting Intense. All right, so first I'm going to deal with the exponents, and then we'll have one long multiplication problem where we're definitely going to combine things. Like I see G in all these, H, J, J. Okay, so we're going to have to combine some stuff. But first, let's deal with the powers. So this one I'm just going to leave. Then this, I'm going to distribute the exponent to each of these. So that gives me -3 squared, G squared. J is to the 4th power, and then it's being squared. So I've got 4 times 2, because a power to a power we multiply. Okay, distributing the 2 here. I've got -G squared, H squared, J squared. All right. These negatives, we have to keep in mind whether we have a negative or a positive, because kind of like we saw up here, if we've got like 3 negatives, it's going to stay negative because it's here we get a positive, and then times a negative gets us back to negative. But with squared, a negative times a negative would be a positive. So I guess I'll do one more line like this. Okay, J cubed, H. -3 squared is going to be a +9. Got G squared. J to the 4 times 2 would be J to the 8th. -G squared. Negative times a negative is just going to be a positive. So that's just going to be regular G squared. H squared, J squared. Whew. Okay, I'm going to switch color quickly. Lots going on. So I'm going to combine my numbers. Okay, -2. This is all multiplication going on. They're all just right next to each other, so that's multiplication. -2 times 9 gives me -18. Let's look at 18. G's. Okay, I've got G cubed, G squared, and another G squared. So when I multiply, I add exponents. So that's 3 plus 2 plus 2. So 3, 4, 5, 6, 7. Okay, then I've got H. Let's see if I can erase just those circles. Sorry. No. Okay, so G to the 7. H, I've got 1 here, 2 here. That's it. So I've got H cubed. And then J, I've got a J to the 8th and a J squared. So 8 plus 2 is going to give me J to the 10th power. Whew, all right, so that's a lot going on. Hopefully it's making a little bit of sense though. So the main part here is when we have a power to a power, we multiply. Okay, when we have lots of stuff going on being raised to a power, we need to distribute that power. And then when we've got a string of multiplication, we sort of combine like terms in a different way though. So we're combining what we can through multiplication. So the like bases, we're combining like bases, I guess we could say. So to the 3rd and squared gives us to the 5th, and then another squared gets us to the 7th, etc. Okay, sorry, trying to wrap this up. These take a little bit though. Okay, this is super fun. We've got product, we've got division, it's all sorts of crazy stuff. Basically, that exponent needs to get to everything in there. It's also going to go down here to the 5 and to the U. All right, so we've got 2 to the 4th, R to the 3rd, then to the 4th, so it's product to a product, we multiply. T to the 6th, then to the 4th, product to a product, we multiply. All over 5 to the 4th, U to the 9 times 4, because a product to a product, we multiply. All right, if I want to simplify this, 2 to the 4th, is going to be 16. Okay, R 3 times 4 is 12. T 6 times 4 is 24. 5 to the 4th. Okay, so that's 5 times 5 is 25. Times 5 is 125. Times 5 is 625. Okay. U to the 9 times 4 is 36. Oh, good. I could have maybe even had stuff to cancel here, too. Could have been another step, but my variables are all different. So that is where I stop. Okay, and finally, last one. All right, 4 to the 3 to the M to the R, down to this 4, down to the P. Okay, so everything gets the exponent. All right, so I've got 3 to the 4th. Let's make this a fraction so I remember. 3 to the 4th, M to the 5th, then to the 4th, power to a power, we multiply. R to the 3rd, then to the 4th, power to a power, you multiply. 4 to the 4th. Rewrite that, sorry. 4 to the 4th, P to the 8 times 4. Okay, and then just simplify that down. 3 to the 4th is going to be, let's see, 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, so I've got 81 times M, 5 times 4 is 20, so that's to the 20th power. R to the 3 times 4 is 12. 4 to the 4th, 4 times 4 is 16, times 4 is 64, times 4 would be 256. Let's go with that. Yeah. Okay, so I've got 256, and then P to the 8 times 4 is 32. Whew. And that is it. Okay, so this is like our complicated case. Okay, this is the craziest it gets, but we have to kind of know the individual rules in order to be able to do this successfully. So there you go. There's your 7-1 and 7-2 notes.